Hello everyone, it's September 7th. It's very early today. It's only 7:15 right now. Well, change of the schedule, so that's why I can do it early in the morning. But it's the same thing, it doesn't really matter. Alright? And here we have a reverse linked list. Could you implement both? No, I will only do it iteratively. Why would I do it recursively? Alright. I mean, I've done this for many times, reverse linked list. So not something. Okay, you know what? Maybe we should try to reverse it recursively. I mean, I know I've written many times reverse linked list iteratively. So maybe it is. It is time to give it a shot, right? To give it a shot, see how we can do it recursively. All right. So, all right. Let's see if I remember right. I'm pretty sure we need a dummy. That's usually how these things go. A dummy, a ListNode. Doesn't really matter, but next what equals head, right? And then I remember we need to have three, right? We need to have the pre-current. All right, so I think pre-current equals dummy and head, right? And we say while current, right? So while current temp equals current.next, right? And then I think it's current.next pointing to hold on. What about pre.next? So pre. Now it's current.next pointing back, right? And then, oh, is dummy gonna be a none? I think. Hold on. Maybe this is none, right? And we say, hold on, man. Current.next pointing to pre, right? And pre equals current, and current equals temp. Yeah, I think that's it. This is a current.next equals pre, and then pre equals current, and then current equals a temp, which I think I can say pre-current equals current temp. And then, oh, then there's no dummy node. And then we're gonna return pre. Right? I think that's it. That's the linked list. Iterative. Try it. Yeah, I'm not gonna write test case for this. No need. Yeah, I think so. Edge case 1, and edge case empty. Yep, I think that's it. Yep, so this is iterative reverse. Iterative. on 36 milliseconds, 70%. All right. So the thing is not like it's difficult or anything. The thing is, now we have to figure out how to do it recursively. It's going to be recursive. Also on, but I expect it to be slower. All right, how do we do it recursively? Well, if we want to do it recursively, we say we have a head, right? So we're going to reverse the remaining, and where do we put the head? Right, so if we want to say, and actually I thought about it recursively. Let's say 1, 2, 3, right? So I'm looking at 1, I say, okay, I need to reverse it, so I need to reverse the remaining. I'm going to reverse the remaining to 3, 2. 1 has to be added to the end. That is not very convenient. How do we add it to the end? We need to have a node pointing to the end. I don't know, man. We need something pointing to the end. So like we have to reverse and we need to return the end node, right? We need to return the end node. That's why we need a dummy, right? We need a dummy, and then so when we do a reverse, we will, or even if we do the dummy, reverse the entire thing. And then return, let's say we return both head and tail. So the last node is going to return 3, right? And now we're looking at this. So we're going to apply into this and return this and this. And the next one, right, we reverse, so we're going to return this and this. Ah, okay. Doesn't seem too bad. Doesn't seem too bad. So I think I'm going to go def reverse. What we're going to pass in as a head, right? I'm going to pass in a head, and we're going to return a node, ListNode. We're going to return the end node, which I think is optional as well. All right, so what do we say? Well, we say if not head, return head. If not head or not head.next, right? Just return head. Otherwise, we're going to run this. Then we'll definitely not return this. Everything will be, just remove all the edge cases. So if, actually I think we can handle it. We can handle head.next. We can handle this case. We don't have to do it the other way. Let's return none. Alright. So we say if not head.next, which is where at the end, we're just going to return head. Right? Otherwise, we're going to say tail equals reverse head.next, right? And then we're going to say tail.next equals head. What about head.next? Oh, yeah. Head.next equals none. And then return head. Right? But how do we get to the head? The actual head. That is interesting. So we return the tail, and then we also always append to the tail, append to the tail, append to the tail. Then there is no way how we can get to the front. So we need to return, let me return two things. All right, we need to return a tuple of ListNode. Right? So it says if not, return head and head. Right? And then otherwise, new head tail equals to the reverse. Right? We have a new head and tail, and then we handle the tail, and then return new head and tail. And then we say reverse head, right? We get new head. I don't need the tail equals this. I think we can just say return this 0. Try it. I'm not sure. That's the first time I ever tried this recursively. This will pass. How about this? This shall pass too. How about regular? 2, 3, 4, 5, 6. Oh, it works. Yeah, it works. I mean, in that case, not head. Maybe we don't need this anymore. If not head, we just return none and none, all right? And then the new head, it goes reverse head on next. Oh, then the new head will become a none. No. The null case shall be taken out. Otherwise, we won't be able to find. Yeah, that's fine. So, is it recursive? How long does that take? Same. All right, let's check. This is right. I don't think this need to check this anymore. Well, we got two easy in a row. Yeah, I was like, this is not a medium question. To compensate for last Friday, I'm pretty much sure. It's 206, right? 206. This is a good question. This is what like people should be doing. I'm gonna have to try to see the recursion. Head equals no. Oh, we pass in list head, and list node new head. The head is not returning head. Next, head on next. Okay, what is this logic? I feel like it's easier than mine. So we pass in the current head. I want to return a new head. And we say current head. A new head. Current head and a new head. If head equals null, return new head. And we create a new list node next equals head.next and head.next equals New head.next pointing to the new head. And then we return next and new head. Huh. I mean, technically this is a tail recursion. I think this is just writing this one in this way. I really don't know. I don't know how the recursion. Are you creating a new head? You're not. Wait, hold on. Are you sure? You're creating a new head every single time, right? I think you're creating a new head every single time. No, yeah. That's a temp. That's our temp, right? That's the temp. Create a temp head.next and head.next equals new head is something at a tail is here. It actually shouldn't say new head. It's actually the tail, the new tail. I don't know about this, but I mean, there's no reason to ponder over this. I mean, it's just recursion. I'm not gonna do it in recursion. It doesn't fit. I mean, this is just we can manipulate, right? It do pretty well. I like to think this way. I think that's how recursion works, right? You take the head, right, and you try to reverse the remaining. That's how functional programming works, right? You take the head, you try to reverse the remaining, and then you figure out how this can work to connect the two. And in my case, I just think we need to return two things. We need to return the head, and the new head is the new head, right? And the tail, and the tail. But on the other hand, oh no, yeah, it has to be this way. Oh, hold on. Do we need a new head? We don't need a new head. I just realized. Oh, actually, that is useful, because the new head is head.next. That is the new head. So all I need to return is the tail. Ooh, hold on. What are you saying? What I'm saying is, I don't need to return do, right? Because this is just return head, right? And we're going to just call new head equals head.next. And then tail equals this, right? New head is head.next. And then, oh. I was just making all these noises. Come on, man. Yeah, and then we reverse it, and I'll get a tail, and tail.next equals head, and head.next equals none. Yeah, and then we return head. Right, return head, because head is the new tail. Head is the new tail. If we only need to return tail, we probably can just, if not head, right, we'll return none, right? Oh, but how do I get the new head out? Well, what we can do is we have something, a self dot new head equals none, right? And then we call, just reverse this. Well, so this is going to be self dot new head equals head dot next. Wait, I am confused. Hold on. What I'm saying is we have this, right? And then we say we're going to reverse, and each time we reverse, we find the new head, because when we reverse, we have the new head, right? We find the new head, and then we are going to record the new head. Basically, every time we just using this to iterate to the end, because after this is done, what we get is the head. Like, we'll return the head. But still, hold on. Where do we get? You know what? Nah, screw this. Head cannot wrap around. I have my way of thinking, and that's it. Yep. Yeah, that's it. Let's just keep it this way. Yeah, that's how I think, right? Because after you return, I need a head, and then I need a new head and a tail. That's what I need. So we do this, we get both, and we just push the new head out, I can do it the other way, but the other way is the same as this. All right, let's just keep it this way. Oh, what the hell? Option. And 2 lines, Y space. All right, that's it. I just call it a day. See you guys tomorrow. Adios.